Hello everyone, I am Hao Hong. I will present the cuTensor-TT high performance third order Tensor-Train and Tensor-Ring decompositions on GPU. Our motivation: tensor decompositions are extensions of matrix factorization to high dimensions. They are powerful in many fields. With the ever-growing demands of efficient big data analytics, developing efficient tensor decompositions becomes a critical task. Existing works do not fully exploit the parallelism of tensor operations, making them impracticable for processing big data sets in machine learning. So, we implement high-performance third-order TT and TR decompositions. We make the following contributions. We implement third-order TT and TR decompositions on GPU. We propose optimization strategies, including optimizing memory access, parallel strategies, faster data transfer, and faster tensor products. We reduce the time and the space cost without the loss of accuracy. We evaluate the performance of TT and TR decompositions with experiments on a Tesla V100 GPU. The speedups of the TT and TR decomposition are up to 6.67 times and 6.36 times over a GPU baseline. This is the TT and TR decompositions utilizing tensor network graph. As shown in figure, the tensor in the form of TT is a train structure and the tensor in the form of TR is a ring structure. Bottom left image describes the procedures of the third-order TT decomposition. The formula at the bottom right describes the relationship between the original tensor and the decomposed tensor. Our optimization strategies. First, we utilize the tensor one-dimension storage in GPU memory to reduce tensor matrixing. Second, we extract the parallel part of the algorithm, including parallel Jacobi SVG, parallel diagonal matrix times matrix, and parallel element-wise product. Thirdly, we utilize streaming transmission modules to transfer data in stream parallel. We tested the algorithms and made comparisons with CPU time, GPU baseline time for both TT and TR decompositions. Here is the performance of third-order implementations. We can see that the optimized implementations on GPU are faster than others. In conclusion, we have presented a high-performance third-order TT and TR decompositions with up to 6.67 times and 6.36 times speedups over the GPU baseline on a Tesla V100 GPU. Our future work will focus on higher-order decomposition, multi-node GPU implementation, and incorporating TT and TR decompositions into the cuTensor library. Thank you.